Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. On today's episode, we're absolutely honored to have Lee Redden, Chief Scientist and co-founder, Blue River Technology, and Chief Scientist of the Intelligent Solutions Group at John Deere. Welcome to the podcast, Lee.
Oh, so great to be here, GB.
I'm super excited to have you here because agriculture is fascinating, and you operate Blue River Technology as a business, and you've solved a really good problem, so I can't wait to dive into this. But before we dive into this, you grew up in the heartland of America in Nebraska, where your dad flew model airplanes and you worked to create smoother runways using giant metal drums. What was that experience like? How did it impact you? I've spent a little time in Nebraska, but never flew a model airplane, just looked at the beautiful countryside.
Some of the things of growing up in Nebraska is we had a shop on the back of my house, and I would spend 4 or 5 hours a day in the back of the shop, just putting things together. I built a couple of go-karts, I built a car. I just have so many fond memories of just being back there, welding something up, grinding something down, and building. And I think just access to kind of all the auto parts stores and all the people around me that were also into cars and had a great environment for me to grow up, particularly on the mechanical side.
Somebody like me, we had wooden matchbox cars, but you take it to the next level and you've got go-karts. Was it you wanted to win the race at the local track? What was the inspiration behind the go-kart? Were you the guy, oh yeah, I'm going to go faster than anybody. Oh, I'm in a corner better than anybody?
Well, from the high school, they were getting rid of some small engines. And so I picked those up for $15 a piece. And they were 6 horsepower and 9 horsepower Briggs & Stratton engines. And I was like, well, now that I have these, I'm going to build some stuff. And we got some steel donated from another source. And I had a welder in the garage. And I just went to town. But I'd have friends over. And it was mainly about like, hey, I think I can actually do this when all the parts were here. And so I spent part of a summer just welding with a couple friends up a go-kart. We did design in pieces where we started at the back of the machine with the engine and the drivetrain. And then, I design about 6 inches at a time, all the way through where the seat was and to where the steering was. And there was a really funny story is that I couldn't figure out how to design the steering in a way that when you turned left, the wheels would go left. So I designed it in a way that if you turned left, the wheels would go right. And I took that out and I drove it a couple laps around the cul-de-sac. And then I quickly realized that was not a good idea. So I went back to the drawing board and re-engineered the steering linkage system. So left was left.
Were you the coolest kid on that cul-de-sac?
Yeah, I was definitely the nerdiest kid on this cul-de-sac. By far the nerdiest kid.
Was it supercharged? I got to know. How fast were you able to get this sucker to go? Did you take it? We had those little mini bikes and we'd race them down the hill because you can get more speed. Did you have like the supercharged engine in there and you didn't have to go to the hill?
The mall was right next door and we took it to the parking lot and we had it going about 35. That was before, because I was just designing it 6 inches at a time. So we got it up to about 35 pre-brakes. And then post that, installed brakes. We found brakes were also a key requirement to going fast. So it was a very fun experience at kind of 14 going through and designing totally from scratch and welding and putting this go-kart together.
You take this incredible sense of using your hands, building something for fun. You enroll at the University of Nebraska and you start building, you want to say cooler or more complex, start building mini surgical robots. How did you go from go-karts to surgical robots?
It's a really great question. I started at UNL in mechanical engineering, and then I really got interested in electronics. And so I wanted to take a step kind of away from designing mechanical things because I saw kind of electronics, and I didn't know it at the time, but computer science was where kind of the magic stuff was going on. And so I wanted to just get more in and do that side of the design. And one of my undergrad advisors had an opportunity in his research lab to design some of the circuit boards for these microcircuit robots. So I just jumped in head first and got to work with one of the PhD students who was designing circuit boards there for many years, and got to apprentice him on a couple circuit boards. And then after that, I was designing my own and just off to the races. And twice a month, we do a whole board spin. And I got super up to speed and just really enjoyed doing research there and took on a whole new field that was just outside of any classes that I had taken or anything that I had learned before.
Were your surgical robots, were they used in surgery, maybe at a teaching hospital or any, in the field, or as my doctor friends of mine say, in theater?
Yeah, we would do testing with them. And so this was animal testing to test kind of the efficacy and if we could get the electronics to work. And so we'd do surgeries every couple months with them once we got to kind of a significant new breakthrough milestone. It was a really good experience because we'd go through a ton of preparation beforehand to get everything ready for what was going to be a big experiment where we'd have surgical doctor present. We're at a surgery center. It's no longer kind of in our lab and is really go time at those times. And so it's a fantastic experience to take and learn how to make a more robust engineering product.
You clearly understand engineering from an early age. You're clearly curious, and you mentioned big experiments. We all look at big experiments, and one of the biggest experiments in robotics was the DARPA Grand Challenge. And when you and I were speaking offline, you said that was a huge motivation, what Sebastian Thrun and his team did with Stanley, for you joining Stanford. Could you talk about the impact that race had on you and why it eventually led you to go to Stanford?
Yeah, I watched the documentary that came out about the DARPA Grand Challenge. I think one of the things of growing up in Nebraska, I wasn't really exposed to a lot of computer science. And what that documentary did was it showed this computer science group that was taking basically a stock car and adding a couple sensors to it, but not putting too many sensors on it. And then it was a computer science problem. And it really kind of paved and showed me the way for what was possible with computer science in an area that I thought was really cool, was cars and autonomy. And I just saw that as like, oh my gosh, if you can make this car do this thing that it couldn't before, it just becomes so much more useful, just totally game changing in the possibilities. And it led me on the path to go to Stanford and led me on the path to pretty much switch careers. I've started mechanical, then did electrical stuff. Then that was the spark to get into AI and machine learning, computer vision, computer science technology. And so since then, I've just been super excited. But that was really the spark and the inspiration to drive down that path.
For listeners who might not be familiar, Stanley won the race. The DARPA Grand Challenge was 132 miles in a little under 7 hours. And Sebastian Thrun famously said, the impossible was achieved. So you're sitting there, you're watching this documentary. Sebastian Thrun said, the impossible was achieved. You're changing your interest more towards computer vision and AI. Did you say, is that when you had like that aha moment? If I took all my knowledge, my hardcore engineering background with this new outlook on AI and computer vision, that I can solve something that's impossible?
Yeah, it's an area where I wanted to work so bad. I was like, I've always been curiosity driven, and I just want to be part of a team. I want to be part of building and doing a solution like this. It spurred me to really add the fundamentals that I didn't have before. And so as a PhD student, I've worked a little bit in between undergrad and grad school, and I don't have the CS background. And it was like, okay, well, how do I get that? I'm auditing and I'm taking classes with freshman CS students. So people like 5 or 6 years younger than I am who, have totally different lifestyle, being kind of 18 on campus versus 25 on campus. But I knew that was what I needed to do to really get up to speed, to work in the field I wanted to. And Stanford was just a great community for that, because you could take and you could audit classes and they didn't block you. Everything was open access. So it just had just a fantastic community for me to basically add in this whole other field that I didn't have before.
You chose to do it the right way. You're not sitting there and skipping around. You sucked up your pride and said, you know what, I'm going to start where I have to start, and I'm going to learn this technology. And you're going to combine that with your hands-on skills. And I believe hands-on skills, and like you're learning in vocational schools or in shop, like you were doing with your go-kart in your car, are skills that you can't replicate today. And you can combine that with your incredible ability of understanding AI and computer vision. You've got something special here. At Stanford, you met a gentleman who you built Blue River with, Jorge Enrolled. How did you meet Jorge, and how did the relationship where you two gentlemen said, you know what, we're going to build a business and we're going to go solve this problem? That's something that might be impossible, but it's not impossible.
So I was at Stanford I didn't know about entrepreneurship in kind of the California Silicon Valley way until coming to campus. And I was looking at kind of how do you go in and build businesses. And I was a heads down PhD student. I'd build cool robots. I was taking the CS classes. I knew that was really an area I wanted to work. But then a bunch of friends and I were tossing around ideas around entrepreneurship, and those were becoming really interesting ideas because you were building something not just for yourself, but for the world. And about a year and a half into the master's part of the PhD program, a friend in lab said, "Hey, I'm going to look at this class." And I went over, and that's where I met Jorge. And Jorge had the proposal around about building an autonomous lawnmower. And I was like, yes, that's what I want to work on. I want to figure out entrepreneurship with something like building autonomous lawnmowers. And Jorge and I hit it off there. The class was taught by a professor, Steve Blank, who takes the scientific method and applies it to business model creation. And so where most business classes to my kind of science and engineering mind just didn't make sense, it seemed like two people go into a classroom and they argue until whoever argues the most wins, and that's how you decide what business you do. He was like, yeah, just come up with a hypothesis, take it out to the real world, test it. And so that's what Jorge and I did with the autonomous lawn mowing idea. And we quickly pivoted out of that and into these high precision weeding, computer vision based high precision weeding applications. And that's where we started the company. And that's what we've been doing for the last 10 and a half years.
When you're going through these pivots, you're trying to figure out the business with Jorge and what the model's going to look like and what the technology is going to look like. What happened when you had the See and Spray breakthrough? Did you two look at each other? Aha, we've got it. There's a niche here, and I have this great saying, and a lot of people say it, but I toot it loud and louder. There's riches in niches. Was that the breakthrough?
It was kind of as part of the scientific method, you have to prove out that the idea that you're proposing. I actually thought we had the breakthrough with autonomous lawn mowing. Kind of the method dictated get out, talk to the customers, figure out the next aspect of it. The idea actually came from a customer. He said, for our applications, we don't want autonomy. We want the job to be done. That job is weeding. We hire hundreds of people to do weeding, and we only have one person operating the machine. And so we saw that as just a big opportunity to come in and automate one of the jobs being done. We verified that 10 different ways, 100 different ways with several different customers. We went through all the different, we knew that we were on it and that the economics worked out and the need worked out when we got to weeding. But then there was the decision of where's the technology at? Where are we at? And what's the best place to start? And so we went into lettuce thinning operations because the technology was there. This was pre-deep learning, so the accuracy was lower out of computer vision algorithms than it currently is. And lettuce is harvested every day of the year in the US because it goes bad otherwise. And so just year-round testing, year-round development, along with the market size being big enough and where the technology was at just made that a perfect starting point for us. Since then, tons of pivots have happened and deep learning has enabled weeding at a much broader scale. That's what we're doing now. But at that time, it was like a deep focus on lettuce and lettuce thinning.
Back then, how were you thinking about scaling the system? Was it based on market demand? Was it based on economics? Or how were you thinking about that?
We were going to start with kind of the customers that we had talked to the most and build a product out for them. And we were just going to kind of start to scale operations. It was robot as a service, which I'm glad has become kind of much more popular as a term since then. But we were really early on kind of build robot to do service as part of the business model. That came from a little bit of the business model innovation that we just kind of pivoted through there.
The robot as a service is brilliant. You have a new company that's joined you in the John Deere family with Bear Flag Robotics, which was the acquisition was announced today with Ingeno and Aubrey, and they're tractor as a service. So I would clearly say you're onto something, and I can't wait to see once Bear Flag's fully integrated with Deere and you put some Blue River technology on their tractors, and away we go. And you got the farm of the future, and John Deere's got two incredible companies running in the stable. When you first rolled out the system to customers and you showed up for demos or for sales meetings, what was the reaction like? Were they like, oh, you guys are crazy, this is never going to work? Or did you run into an individual, and Ingeno and Aubrey have said this, oh my God, this works, you're going to save me, I can actually grow my farm and expand?
The first folks that we talked to, there were a couple kind of true believers in there. And I think one of the things with working with farmers that's amazing is that they know their bottom line numbers just off the top of their head. They can go through and they can spit, and you can spit out those numbers. They can do the calculations of if you did this or if they changed that, what would happen? Because they're making day of decisions all the time about what to apply, what to change, what to do on the marketing side, what equipment to run, who's available. Farmers are just incredibly agile and make so many decisions. And so when talking to them, I found actually of any group of people to talk to, they're some of the very best to talk to about the business model creation because they're so knowledgeable. And you can ask them the question of like, hey, if we did this, what would happen? Yeah, I've really enjoyed kind of the farmer side. So we pivoted through them and a couple strong believers in us, even when we came out with kind of a wooden box with a webcam hooked up to it that was viewing things they could see like, okay, this group actually has legs. We'll let them do some trials on our field. And then it was one day we had done lots of trials and we were spraying water. Then Jorge had the conversation with them of like, hey, I think it's ready. We'd like to make the switch. And they came out and viewed it and said, okay, yeah, do this section. And if you do well on that section, we'll give you a larger section. And if you do well there, we'll give you a larger section. And that's how we operated. I think one of the great things about farmers that played to our advantage is they aren't big believers in PowerPoint presentations. They want show me in my field. I want to see it working, operation going on. That actually played really well to our advantage because it wasn't about kind of a smoke and mirrors or dog and pony show. It was put the tech together, get it to work. We build engineering products. And so that's our specialty.
Farmers are amazing human beings. They feed the world. They grow great food. They keep us healthy, and they're really good, down-to-earth, hardworking individuals. And being a farmer is a back-breaking job. And to the farmers out there, if you're listening, thank you for making this incredible produce and everything you do on the farms, because we really thoroughly enjoy it. We don't thank you enough for the amount of dedication and time you put into feeding not just the United States, but feeding the world. So thank you so much. I want to dive into the See and Spray system here. Could you talk about how the system works, why and how it's so accurate, and if you're going to go to, let's say, Acme Farm, what the process looks like to deploy the system?
The system's set up that it has a series of cameras, and the cameras detect every individual plant. And then we have a bank of actuators, and we spray just the areas of the field that we would like to. And so depending on if you'd like to spray just the weeds, we can. If you'd like to spray everything but the crop that you're growing, we can. And so all of that is kind of infinitely easily set up by kind of the tech stack that we've built there. So it has both this very high precision on the ability to do plant-by-plant care. So it's enabled by, we have cameras hooked up to banks of GPUs that go through and process images in real time, make all those decisions, and then it's a real-time robotic system. So the actuators are firing as you're driving over the field.
Do you have to use specialized cameras, for instance? Perhaps a rock might jump out or mud might splash up if it's the field, if it just rained. Do you have to, I guess you want to use the word harden the equipment? Does any of that have to go into that?
So all the equipment goes through a hardening process for the electronic side. Some of the things that you had mentioned with kind of rocks jumping up or mud in front of the camera, those are things that would just happen during normal operation. In our previous businesses in lettuce thinning, what we would do is we'd have detectors for that. We'd notify the operator to come out and to clean the camera when that happened. And so we had, there's kind of this really glorious computer vision algorithm that is the one that detects every individual plant and pulls out in parameters about that to make decisions on what to do. There are at least 10 times more detectors out there that are for this robustness. So is the light to the camera good enough? Is there mud or dirt on the lens? Is there a smudge going on? And is the timing of the frame capture how we think it should be? So we have all these detectors, and for many of them, we'll either make a notification to the operator if there's something that they can go do to do the corrective action, or it'll be an internal systems notification.
You're a pilot. When you have the tractor that's going to go out, does it do like a pre-flight inspection where a farmer goes around, checks all the sensors to make sure, okay, everything is clean, very similar to when you're going to take your plane out? You do a pre-flight inspection, do a pre-flight farm inspection?
Yeah, GV, great question on this one. We were having, in our lettuce thinning days, we were having a problem with missing stuff. And we set up a checklist for it because these systems are complicated. It's easy to miss stuff. And so the operators on a daily basis would go through checklists, make sure everything was kind of tight and ready to go before we went out. And you add stuff to the checklist until it's pretty robust, and then you remove stuff from the checklist until it's streamlined. And so that way we could more systemically figure out how to get the most robust application, but not be too cumbersome over on the operators. And a lot of that we'd actually try to build automated features for. I think this is one of the areas where I have always underestimated how much work it takes, is to go in and build the automated features to take the machines and check everything on it. And the larger scale you get to, so if you're shipping 10 times as many machines, kind of a general law would be you need about twice as many subsystems that are doing these checkings. And so every order of magnitude more machines you ship out, you need about twice as many subsystems checking.
Is that another way of saying redundancy, that redundancy is built into the system?
Yeah, that we're building kind of this redundancy self-check into the system. And so if to keep driving down the error rates that we build in redundancy, sometimes it's actually simplifying the machine. I think simplifying the machine has quite a big effect. So make sure you get your requirements and your design right before going in and automating the aspects of it or robustifying the aspects of it. But we've done several major recalls on the tech and the organization of it around simplifying everything.
Tractor's getting ready to go out. The individual went and did his pre-tractor inspection. Do you have to go and pre-map it or anything along those lines before the tractor can go out, or can it just go out no problem?
We have a driver. They're still driving. You could connect it to the GPS system and have it do that, do hands-off steering on it. And they drive through the field, and nothing, you load in which crop you're in, and it goes through and it sprays. So nothing pre-mapped. The machine is capable of capturing all the information it needs on board. So you say, okay, I'm in a cotton field, and it's capturing all that, loads of the cotton model, goes out and sees every plant and sprays just the weeds.
No pre-mapping. The individual just selects the crop that's there. And then is that where your computer vision and deep learning comes in to identify those weeds in the fields?
Exactly.
Does that vary where if you're working on a farm, say in Northern California, where the climate's different from Nebraska, or if something's planted closer to another, or the terrain, or certain times of the year where the sun might hit things differently? Does that play a role into all that, where your system has to be calibrated to the local climate?
Really good question on that. We need to capture data and have specific weeds of your type of field in our data set. And so we basically choose geographies that we're going to be operating in and go out and capture data for those geographies. And so we're shooting for a diversity of geographies to be able to have the data sets that we can then come out and take the machine to then work in that diversity of data sets. The other thing about it is, like, if it currently doesn't work all that well or high performant in that specific geography, and the machine's there, it will be in capture mode to capture that data, label it, go up to the cloud, train, and then bring back down a model. Machine learning engineers are currently in the pipeline for doing that and can check and make sure that the model is doing better as it would come back down. We've done some significant, when we first started this project, we went to Australia, second hemisphere type testing. It was summer there. We captured data. We then had that to test against when we came back to the US and wanted to build a model for cotton in the US. We noticed that there was a significant difference between the two, but the pipelines transferred and the knowledge from one geography transferred to another, but the actual data didn't transfer all that well. So it just gave us the heads up, like, the diversity of data that you have really matters.
Is Blue River technology currently being used around the world, or is it just operating in certain markets today?
We're kind of pre-operating on the farmer level, so we're pre-sales, but we have several test machines that are going around and operating, mostly in the US.
In 2017, John Deere acquired your company. Is this technology actively being integrated as an option for John Deere tractors for the farmers around the world?
This year, John Deere announced a see and spray option that was kind of green versus brown spray. I don't know exactly if that is where that's being offered and everywhere. I'm more on the tech build out side than the marketing and sales side, but we're excited to see that kind of come out. And I read the press releases and saw that I think we're selling it someplace, but I'm not totally sure. But we have that, and then there's a lot more cool things to come.
It's a clear validation of your product and your hard work. John Deere is an international iconic company, and I know some individuals that work there. And to the folks at John Deere, if you're listening, please, I'd like the hat and the shirt, because I heard you get airplane upgrades if you wear the shirt, because everybody loves Deere. So please send me one. You've been a part of Deere now for 4 years. You went from startup inside of Deere, but the cool thing, and I give Deere management a lot of credit, they're letting you run this thing like a little lab, which is really cool. What's that been like to have the resources of this incredible, iconic company, but yet still have all the ability to do really cool, innovative stuff like the video your team posted on LinkedIn? That thing was cool, with the tractors doing all this cool, fun stuff with actuators.
It's allowed longer view on the development of the technology. And so previously we were very much kind of quick revenue, show growth, be in customers' hands. And so part of Deere, we're not always looking for that next funding round that's going to be 18 months away. We can now take and have a focused view on what the longer term future looks like. So that's been really fantastic for the company to be able to have that longer term view. For myself, I took a step back when the acquisition happened, and I said, okay, well, now we're part of this larger organization. Where could I work to do the coolest work and be the most effective? And I saw control systems come up. And so I think through Blue River Technology, we have so many amazing projects around computer vision. The See and Spray project is the flagship one coming out. It's a 2-decade, 3-decade style change in agriculture. It's going to be the biggest thing since bioengineering came and had major effects on how agriculture is done. And the See and Spray product is going to be that with perception systems. And so after working on perception systems for 7 years, I said, okay, across the fleet of John Deere machines, control systems is going to be one of the next big waves. And how do we make a big splash with this? And so we have machines that can go up and go into weird angles, and they can spin very fast, and we're shooting for kind of Boston dynamics of agriculture and construction. And we're putting together a team. We have some great members of the team, and we're expanding it to have even more, to be able to come in and make super dynamic, super agile machines that do operations that just weren't previously possible before. And it's a natural flow once you have perception across these machines to have very good controls and dynamics that take advantage of that perception.
You said something to me offline that you view Blue River as John Deere's Bell Labs. AT&T, Ma Bell, we'll go back to Ma Bell. Some incredible innovations, being able to call from San Francisco to New York, Bell Labs. All these incredible innovations that went on to have a profound impact on society came out of Bell Labs. What are you hoping to achieve in the statue of Bell Labs with Blue River? Are you to have that big breakthrough moment that will have an incredibly positive impact on society?
I mean, the See and Spray product is that it's a win-win-win all the way around. It's reduction in herbicides, it's reduction in cost for farmers and more control, and it has an environmental impact that you're applying less. And so it's a clear win-win-win all the way around. In addition to that, bringing perception systems so that farm equipment can operate on a plant-by-plant level, which was just not previously possible before, to other pieces of equipment and other machines. And then the thing I'm excited about on the research front, really pushing forward, is this control systems. I think we'll see shifts in machine form and how machines are designed and put together based on control systems. I think, we've seen this in other areas. This is rockets that can come and land on pads because they have fast model predictive control coming in and working, and it just totally changes the whole space industry because of that. It changes rocket design, and now tons of rockets all come and land, and amazing tech like that coming out from Blue River.
The current control systems advanced enough to allow you to fulfill your vision and dreams of what you want to do with farm robots?
Not the current state of the art. I think we really need to come out and push the state of the art even farther than it currently is to be robust and agile on farming and construction robots. And we're doing the research. I think that there's a lot of moments, kind of like when Blue River was started, that the computer vision was able to do lettuce thinning, but it wasn't able to do weeding applications because the computer vision precision and recall weren't high enough. And so we worked a long time to get that, and deep learning came out and was the major enabler for that. I think control systems is also in or going to be deep into that renaissance. And, there's a bunch of technologies that are coming out, but applications like rockets that land themselves and humanoids that are walking and robot dogs that are walking and in other various autonomy with cars driving control systems to be better and better. I think we need some of that, but we also needed a healthy mix of innovation and really innovation applied to the specific applications that we're on: dirt moving, dirt hauling, modifications, high speed with hydraulics, to really have and see the fruit through agriculture and construction.
Agriculture is becoming more and more of a hot topic now, where more startups are starting to realize the potential in agriculture, the potential positive impact on society, and they're also realizing the business opportunity. And prior to your See and Spray system, there is really no way to go find all these weeds, because there's 250 species of herbicide-resistant weeds and uncontrolled weeds, resulting in annual losses of approximately $43 billion in corn and soybean crops. Is this where the computer vision and the deep learning comes in, for you can identify those weeds, so you can go to let's call it your customer, Acme Farmer, and say, hello, Mr. Farmer, hello, Mrs. Farmer, hey, we have a solution that's going to save you a lot of money.
Exactly. The product will, in kind of its dreamed manifestation, will be able to go in and control weeds and these herbicide-resistant weeds in fields. And at that point, the farmer has very few options which they could actually take out to control those weeds.
Staying on the herbicides theme, your system, the Blue River See and Spray, reduces the amount of herbicides used by 77%. I repeat, 77%. An extremely positive impact to the bottom line on the farmers, but a very positive environmental impact. It seems to me that this is the perfect solution. What are your thoughts?
I think higher precision and plant-by-plant care is a win-win-win situation. It's one where I think technology really enables win-win-win type situations, where I think oftentimes you're stuck with kind of a fixed pie, but we can make a product that is more precise and uses less, so the farmer pays less, uses less because it has better environmental impacts, gets higher yields out of the field. And so just in the whole ecosystem, a product like this has win-win-win type effects.
Higher yields are going to be crucial, because the World Bank's projecting the global population to be 9.7 billion by 2050. We've got massive global growth. Society's going to need to feed another billion plus individuals. So higher yields are going to be key. How can automation on farms help with this global population boom? Can we get higher yields? We combine automation with your system so we can put more healthy food in tummies?
Automation and digitization and precision, really precision down to the plant-by-plant level, is the next big revolution in agriculture. And the See and Spray system does exactly that. You'll see it proliferate to other machines also. You should see technology like this move into planters and move into harvesters at some point. The needs are a little bit less there because just the actions that go on. And so kind of the first clear major benefit is See and Spray. And that's because a lot of the inputs, that's the step in the process that inputs are coming in and being added to crops. I think what this sort of thing does is that we would see as kind of a hit in yields due to herbicide-resistant weeds coming in. But technology like this enables us to not have that decrease or that hit in yields.
You're building something that's profoundly impactful. Okay, you figured out See and Spray. You've got this incredible mind to build really cool things, go-karts to cars to See and Spray. I got to know, what's up there cooking in your mind next? What's after See and Spray?
That for me is control systems. I want machines out there in the world to not just kind of see and take great actions, but to also have the agility of ballerina. And to take the information that's coming in and really move through the world in graceful and smart ways. So that's where I see I see control systems as this research area, kind of like computer vision was many years ago, that you can come in and we put the right systems together. We can make machines that are very graceful while also being very strong.
I got a hunch you're working on something very special over there.
Yes. Yeah. Absolutely.
Putting this really insightful conversation into perspective, your secret little mission on control systems, which I hope you come back when it becomes public to talk about it. What is the future of the ag business?
See and Spray comes out and has just a major effect. You see intelligence start to come in more machines than just sprayers. You'll see the connection from machine to machine. And so your planter makes your sprayer better. Your sprayer makes your harvester better. Your harvester comes back and makes your planter better on a yearly cycle. So John Deere as a company is focused now on making machines that work with other machines, doing different operations. And I think we'll see some very cool projects come out of that have very large customer benefits, because we're able to put together and do things at different times in the growing season that can really make the farmer more efficient.
You're optimizing farms with See and Spray. You're making the world a better place so people can get really healthy produce from farms. You're helping farmers save money, get higher yields. I wish you nothing but success with Blue River, because I'm telling you, you're onto something really special here. You've got the resources of an incredibly important company. And again, John Deere, I love a hat and a shirt so I can get my plane upgrades. So keep doing what you're doing, Lee. And as we look to wrap up this insightful conversation, what would you like our listeners to take away with them?
There's a lot of really interesting things happening on the computer science side in agriculture. The next wave of agriculture is not mechanical, and new innovations coming out on the mechanical side. It's in the computer science realm. And so folks that are looking at working in it, whether it's at a startup or whether it's at a big company, they should take a hard look at, computer scientists in specific should take a hard look at agriculture and see lots of opportunities for them to work in that space. I'd be encouraging of everybody in that field, because for me, it has been a really fantastic area to work in, with a bunch of promise and a bunch of great effects that have come from that.
Blue River is also hiring. If an individual listened to this and said, wow, Lee's vision is something I want to be a part of, where can they go to learn more about Blue River?
You can go to our website and check out the jobs page, or you can reach out to the folks just directly. If there's an area that you didn't see a position that you think that your skills would fit very nicely, but it wasn't listed on the website. We are people, we have tons of ambitions of what we're doing. And if you have ambitions that you think that we should be working on, please reach out through that website.
Lee, what's the website address?
BlueRiverTech.com.
BlueRiverTech.com. If you want to build the future with Lee and his team, they're doing really great, incredible things. And Lee, thank you so much for taking time to come on the Road to Autonomy, talk about your incredible vision with See and Spray, because it is going to have a positive impact on the world. The future's bright, the future's autonomous, and the future is Blue River's See and Spray. Lee, thank you so much.
Excellent. Thank you so much, GB.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy, or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed in this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.